Okay, in this video we want to look at some of the features dealing with the planet Venus. Now, one of the things that's interesting as Venus is that it's often very easy to find in the night sky because it is the brightest object in the sky after the sun and the moon. So if you're looking at the night sky, the moon is the brightest thing out there, but next to the moon is Venus. And in fact, if the moon is completely dark, then Venus will be the brightest object in the sky. Now, sometimes Venus is called the morning or the evening star because, like Mercury, it's kind of quote unquote tied to the sun. You'll find that the best time to view Venus is around sunset or around sunrise. And one of the most interesting things is that even though Mercury is closer to the sun, Venus is much brighter. And we'll talk about why Venus is so bright later in this presentation, but it is incredibly bright, and that's one of the reasons why it was named Venus. It was named after the Roman goddess of love. It was seen as this very bright, luminous object in the night sky, and ancient people looked up and thought it was beautiful, and so they named it after the goddess of love. And it turns out that name is a little bit ironic, but we'll get to that shortly. Now, we talked earlier in the semester about how Venus has phases, but that the phases are different from the way that the moon has phases. And the behavior of the phases of Venus was one of the things that actually proved that the sun was the center of our solar system, not the Earth, the heliocentric rather than the geocentric picture of the solar system. So here is a picture showing the sun and Venus in different positions relative to the Earth. Okay, so we have a screen showing some of the physical properties of Venus. The first thing that we can note is the radius is about 6,000 kilometers. Its mass is 4.9 times 10 to the 24th kilograms. This is very comparable to the size of the Earth, which is about 5.9 times 10 to the 24th kilograms. And so you can see 4.9 compared to 5.9. Venus is very similar to the Earth in its size. The Earth's radius is about 6,400 kilometers. And so you can see in terms of size and in terms of mass and in terms of density, we find that Venus and Earth are very, very similar. In fact, Earth and Venus are so similar in so many ways. Astronomers used to say that Venus and Earth were almost like twins. Now, one of the things that's very interesting is the rotation of Venus compared to the other planets in the solar system. Particularly if you look at the rocky planets, which include Mercury, Earth, and Mars over here, you can see in this diagram, you can see there's a little circle here showing the direction of the Earth's rotation around its axis. Here you see a circle showing Mars's rotation and Mercury's, and they all rotate in the same direction, except Venus rotates in the backwards motion. Now, remember we have this word retrograde, which indicates a backwards motion. We talked about the retrograde motion of the planets in the night sky. Well, this is a retrograde motion in terms of rotation. Venus actually rotates backwards compared to the other planets in the solar system. And another weird thing is that it rotates really slowly. One Venus day is equivalent to 243 Earth days. So that means that Venus is rotating about its own axis incredibly slowly. So why does Venus rotate backwards? Basically, the current theory is that at some point in Venus's history, it kind of turned upside down. And we'll see later on that you can see that the Earth's tilt is at an angle and Mars's tilt is at an angle. There are other planets in the solar system that have even more extreme tilts than those. The idea is that basically at some point Venus flipped over and basically turned upside down so that its rotation rate is backwards compared to everything else in the solar system. Now, why does it rotate so slowly? That may be because of its incredibly thick atmosphere creating friction effects. But all the details of why Venus rotates so slowly are not really fully understood yet. So that's something that astronomers are still trying to puzzle out. Now, a few things that make Venus very different from Earth are how incredibly thick and dense its atmosphere is. This makes surface features impossible to see from space. And the other thing, and perhaps the most prominent thing about Venus, is its insanely high temperature. Its temperature is 730 Kelvin. That's almost 900 degrees Fahrenheit. And the surface of Venus is hotter than the hottest part of the surface of Mercury. That's what's crazy. Venus is way further from the sun than Mercury is. And Mercury is basically just a rock, just absorbing all that heat. But Venus is hotter still. And we'll see why that is shortly. Now, we'll talk more about how dense the atmosphere is, but it's so thick that probes flying by the planet, they can't see anything on the surface. Not even ultraviolet or infrared radiation gets through the atmosphere. So the only way that we've been able to see anything about the surface features of Venus is to actually land probes on the surface of Venus. Now, we have actually landed probes, and we've been able to use radio waves to do some mapping. But the problem with using radio waves is that you can't get a very good resolution. The wavelength of radio waves is really long, and so that means the pictures you get don't have a lot of detail. So that's why it was very important for us to land probes on Venus to get a better picture of what the surface looks like. But some things that we have discovered, we know that the surface is relatively smooth, and that can be indicative of things like erosion. There are two continent-like features, and they're named Ishtar Terra and Aphrodite Terra. You may know Venus is the name of the Roman goddess of love, and Aphrodite is the name of the Greek goddess of love, basically the Greek version of Venus. You may have learned before, if not, Ishtar is the ancient Mesopotamian goddess of love. And so these goddesses, Ishtar and Aphrodite, are related to Venus from mythology. And so that's why those names were chosen. There are no plate tectonics on Venus. It doesn't seem to have plate tectonics in the way that the Earth does. But there are mountains, and there are some craters, and there are many, many volcanoes, and there are also very large lava flows. On Earth, there are maybe 1,500 volcanoes. On Venus, nobody knows how many there are, but the estimates range somewhere between 100,000 and 1,000,000. So vastly more volcanoes on Venus than there are on the Earth. Here is a couple of maps indicating the surface of Venus. You can see here the elevation, so you can see the green and the orange here represent a higher elevation than the blue. This blue does not indicate water, it's just indicating the height of elevation. These, you can note from the legend here, these images were made with radio waves, and so these are false color images, but it does show some of the prominent surface features on Venus. Here we can see a couple of maps. Here's a map of what Venus would look like compared to the Earth. And you can see it blown up here a little bit, showing these elevations. But that's basically what the continents on Venus look like. Here you can see a shot of Ishtar Terra, which is one of the two continent features, and this shows Maxwell Montes, which is the highest point on the surface of the planet. Here is a shot showing some of Aphrodite Terra, which is the other major continent feature, and again, you don't see a lot of detail here because these images were made with radio waves, which don't show a lot of detail. But of course, radio waves are the only kind of electromagnetic radiation that can penetrate through the incredibly dense atmosphere that Venus has. Here you see a lava flow that's come from a crack on the surface, and you can see, this from here to here is 20 kilometers, so that's 20, 40, 60, more than 60 to 70 kilometers. That's roughly the distance from here in Senatobia, Mississippi to Memphis, Tennessee. So it's a pretty long stretch. And we know that, one of the reasons why these lava flows can stretch so long is simply because the surface temperature of Venus is so hot. The lava doesn't have as much of a chance to cool off and solidify like it does on the Earth. Lava from a volcanic eruption on Earth would solidify and cool off relatively quickly, but these lava flows, they can take a long time to solidify, and they can travel long distances. And here we can see another prominent feature on the surface of Venus. This is a crater that was named after Margaret Mead, who is a famous anthropologist who had a lot of impact on American culture, and I guess the world's culture as well. Now, here's something that I think is pretty special. This is actual photographs from the surface of Venus, which is really cool. So Russia, actually, the former Soviet Union, was able to land probes on the surface of Venus that were able to make these photographs. And what you can see, the features here, it looks not necessarily alien. If I told you that this image above, if I told you that this was, from a crater around a volcano in Hawaii, if you weren't intimately familiar with the landscape of Hawaii, you might believe that as a perfectly reasonable thing to say. Obviously, I'm not saying this. This is a picture of Venus, but it's kind of Earth-like. It doesn't really look alien, and so that's pretty cool. You can see these rocks and the land and the pebbles and the dirt. It kind of reminds us of home in a lot of ways. Now let's look at the atmospheric features of Venus, because they are part of what drives so much of Venus's climate. So the first thing that we can note is the pressure, and we can see that at the surface of Venus, if we look at the right side axis, we can see the pressure in bar, and we can also compare that to the altitude in kilometers. And so if I look at 100 kilometers, I go over to my little blue line, and then I can trace straight over and see it's about 10 to the minus 4 bar here, a little bit less than that. If I go down to the surface, however, I find that the atmospheric pressure at the surface of Venus is roughly like 93 times bigger than the atmospheric pressure of the Earth. That's roughly equivalent to the water pressure you would feel being about 3,000 feet underwater. It would be absolutely crushing to be on the surface of Venus. You would feel that pressure squeezing you like crazy. So the surface of Venus is kind of like what many people imagine hell to be like. If you were to be teleported to Venus just magically without some kind of protective spacesuit, you would be essentially crushed by the incredible atmospheric pressure, and then you would be roasted alive and rapidly turned into a charcoal briquette-like object. You would just be killed incredibly quickly, and it would hurt the whole time you were dying. And what makes it extra fun is that the atmosphere is mostly carbon dioxide, but it does have sulfuric acid cloud layers, and there is actually sulfuric acid rain on Venus, although it doesn't generally get to the surface of the planet. If you were up a little bit higher, you could be dissolved by the sulfuric acid, which is, kind of nice too. So Venus is not exactly some place that we would consider a vacation spot, or at least not a good vacation spot. Now, the other thing is to note is that the atmosphere is mostly carbon dioxide. It's something like 95% carbon dioxide. And that's the reason for its temperature being so high. Spoiler alert. And here's the point. We've talked about the fact that Venus has mostly carbon dioxide as its atmospheric component. And we've talked about the fact that carbon dioxide is a greenhouse effect gas. And so, because there's so much carbon dioxide on the surface of Venus, it retains most of the heat, and that causes it to be even hotter than the surface of Mercury. And so we have this images here comparing the greenhouse effect on the Earth compared to Venus. Now, a few things that you can note in this feature and that are featured in these images, like consider here the incoming sunlight arrow here compared to the incoming sunlight arrow on Venus. So the blue one is the Earth, the orange one is Venus. This arrow on Venus is fatter than the incoming sunlight on the Earth. And the reason for that is because Venus is closer to the sun, it gets more sunlight, it gets more intense sunlight. You might think that that's the reason why Venus would be so much hotter, is because it's closer to the sun. But it turns out not to be true, because look at this. Look at how much sunlight is reflected off of the clouds of Venus. It's a large percentage of the sunlight is reflected. Most of the sunlight that strikes Venus doesn't make its way to the surface. That's why Venus is the brightest object in the night sky, because most of the sunlight that hits Venus is just reflected back into space. And so you can see the part of the sunlight that actually gets through to the Earth is very comparable to the amount of sunlight that actually gets through to Venus. Venus might be a little bit bigger, but it's very, very close. So the surface of the Earth and the surface of Venus receive essentially very similar amounts of sunlight, and yet Venus is hundreds of degrees hotter than the Earth. That's because Venus has been subjected to a runaway greenhouse effect. We talked about how on Earth there are feedback mechanisms that drive global warming to higher and higher temperatures. These kinds of effects played out on Venus for millions of years. Now we can see here that on Earth, the sunlight comes in, it warms the temperature, and then the Earth radiates this red, which is indicative of infrared radiation, and some of that infrared radiation gets trapped, some of it gets re-radiated into space. On Venus, the same thing happens, but because you've got 95% of the atmosphere being carbon dioxide, most of the infrared radiation is radiated from the surface, gets reflected back down and gets absorbed by those clouds, and only a tiny bit gets radiated into space. And so basically Venus doesn't have the ability to regulate its temperature in the way that the Earth does. More and more heat gets trapped, and that's why the surface of Venus is so incredibly hot. And lastly, just a few points about some of the features we know about Venus's internal structure. We do not see any evidence for plate tectonics. There may have been some sort of plate tectonic activity in the past, but there's no evidence that that exists today. There's also no magnetic field, and that's probably because the rotation rate of Venus is so incredibly slow. Venus resembles kind of a young Earth, maybe at about 1 billion years. There's no asthenosphere, there's no thin crust. It's just a thick crust that seems to be composed of things like silicate rocks, but that is what we know about Venus. Now, I said earlier that some people say that because Venus has so many similar features to Earth, similar composition, similar size, similar mass, some people even think that earlier in Venus's history it once held oceans and maybe even was hospitable to life before the runaway greenhouse effect turned it into a hellscape. But because the surface of Venus is so hellacious now, a lot of people like to say that Venus is Earth's evil twin, Now, of course, not literally evil, but the distinctions and differences are very clear. And hopefully you found some of this interesting, but that is some of the main things that we know about the planet Venus.